Okay. Okay. Can you don't need a laptop, you can lower it. Thanks. Yeah. There you go. Perfect. Thanks. All right. So transformations. What guys, we're getting started. What transformations have we covered so far? So think about Ollie, go ahead. Right? Correct. So we've done rotations, we've done reflection, and we've done translations. And all these are called rigid, meaning they don't change the size. The size of the object never changed at all. So like you guys have already done reflection and translation in the project. You'll do rotation later today. But they're rigid because you didn't change, you didn't like scale it up or scale it down, right? You just kind of just kept everything the same size. So when you hear the word rigid, it means the size does not change.
Wait, what is it? Is that saying we're
Reflections. Yeah, my handwriting sucks. I should use my iPad, but that's all right. So rotations, reflections, translation, size does not change. That's what rigid means. Um, of course, this is a lead to the next thing we're going to talk about. Lucas, can you read 3.2, please?
Sure.
Yeah.
Today, we will investigate the different non-rigid transformations for dilation. You can think about dilation as a stretch or stream from the depth. If we were to stretch ABC with vectors 3 from the located edge in diagram number 2 below, we specifically how to dilate a figure.
We'll discuss as a group. So, like for example, if your pupils are dilated, like they kind of like expand, right? So, um, dilation just means stretching or it could be shrinking too. Um, so in this case, if you look, probably the best thing to do is state the coordinates for point A. Where are the coordinates of point A right now? Just look at it. Where are they? 3, 2, perfect. Now look at the coordinates of A prime. Where are they now? So how did that change compared to A? Yeah, go William. Multiply by 3. Perfect. Thank you. So you multiply. You could say, yeah, that works. You can multiply by 3 or stretch. And actually, we do say that as a formality, what Pierre just said. You stretch by a factor of 3. So that also the same thing. How I do prefer the more formal way of stating it, stretch by a factor of 3. But multiply by 3 is good to know because you need to know mechanically what you're doing to the coordinates to get the new coordinates. So yes, from a quantitative perspective, we do need to understand that we're multiplying by 3. But the more proper way of stating what you've done is saying it's stretched by a factor of 3. And kind of weird, we call this a stretch point. I guess you just extend A prime off that line. That makes sense. All right, so let's try that for a new problem. Let's go part B. Okay. Reagan, can you read part B, please? Thanks.
Dilate quadrilateral ABCD from the origin by factors 2, 3, 4, or 5 to form A prime, B prime, C prime, D prime. Each team member should be a different enlargement factor. When you're finished, compare and contrast your figures.
So actually, I think you guys can handle all these in each of your table groups. So what I'm going to do is going to do a table. That's probably the best thing to do. So I'll make see if I have enough room here. Hold on, let me all right, here we go. And actually, sorry, I'm making an update to this table. Sometimes when I teach for the first time, I do make mistakes. Okay, so, gosh, I didn't really.
How all that space to write that?
Yeah, I kind of screwed up. You know what? I really screwed this one up some royally. Yeah, thanks.
You're on the front. Yeah. Or like the back of the packet.
Yeah, yeah.
Yeah.
Okay, hold on a sec. Let me do this one more time. Gosh darn it.
Constantly.
Okay, here's what we're gonna do. Point, original, dilation factor. And the more I think about it now, we actually will do this in teams. So you guys get 2, you get 3, Cam's gonna get 4, and the back get 5. So here's what we're gonna do. I'll do for the group of 2, I'll do it for you guys. So points A, B, C, D. What are the coordinates of point A? 3, 2. What are the coordinates of point B? They 1, 2. Point C. -2, -2. -2, -2. And point D. Perfect. Okay. So then I'm not gonna have you guys dilate all 4 of these factors in your groups because that's just too much. So like the group with William, Lucas, and Peter, you guys are gonna have dilation factor 2. So since they have dilation factor 2, what are they gonna do to each coordinate?
Increase it by 2.
So they'll have 6, 4. What will the next one be?
-2, 4.
Then
-2, -2.
4, -4.
-4, -4, right?
Yeah.
Okay, good, no worries. And then 2, comma,
-4.
correct. Okay.
Good job.
So for the other groups, so the group with Kira, Reagan, and Zoe, you'll do that times 3. So me and Cam, you do times 4. Faith, Ale, and Connor, you'll do times 5. Okay. So for example, for the group with Lucas, William, Peter, they're going to be plotting 6, 4, which is way off here. They're going to plot -2, 4, which is way, not way, but over here. Then they're going to do -4, -4. Yeah, you guys are 3. And then D was what? 2. Okay, let's use different colors so it stands out.
Stop.
You guys quiet, please. Thank you.
So cute.
Okay, so that's A prime. That's B prime. That's C prime. Okay, so I basically did. Actually, that should be a B. Looks like a D. Let me fix that. So what happened here? We dilated the original shape by a factor of what? 2, right. So it means that all the sides doubled, essentially, right? If I were to measure, for example, how long is BA? If you count it. BA. 1,
1, 2,
4,
6.
4.
That's good.
So how long would B prime to A prime be? 1, 2, 3, 4, 5, 6, 7, 8.
8.
So we double, right? Or likewise over here, I mean, if you count from like CD, that's 1, 2, 3. C prime, D prime, 1, 2, 3, 4, 5, 6. Now we're not gonna have this discussion until next semester, but area. How much more area do you think I got?
Times
Times
2.
Times 2.
Not times 2.
Plus
Times
2.
So let's say 4,
I said 4.
but not plus 4, but
Times
Said times
oh,
4.
I said plus 4, sorry.
Yeah.
Yeah, times 4. The reason why is
2
because
squared.
right, 2 squared, exactly.
Okay.
So we'll have that discussion next semester. So you actually the area got quadrupled. So for the other groups, you have times 3, times 4, times 5. Let me show you the answer key. Here's the answer key.
I got for the 3.
Good, perfect. That looks excellent. Thank you. Yeah, so it should look something kind of like this. So for example, the group in the back has got 5. You guys should have something like this here. And actually the area goes up by 25 times as much. So it's a much, much bigger area. So,
Oh,
okay. Let's keep moving. All right. So let's talk about the next part. This is actually kind of an important thing. Cam, can you read part C, please? Okay, so there's actually 3 things we could say. One thing is that you'll have the same, I'll do this bullet points, same angle measurements, same number of sides, and same relative slopes of the sides. So you don't have to draw this, but one of the sketches look like this. And then when we doubled it, it kind of looked like that. Okay, and I didn't draw it very well. But whatever angle this is, so if you look at A, I'll wait till you guys are what this is. You look at A and A prime, they'll be the same angle. Or B and B prime, same angle. C and C prime, same angle. B and D prime, same angle. If you also look at the number of sides, of course, 4 sides, 4 sides. If you measure this slope and this slope, they'd be the same. So you get, you're just scaling it up or scaling it down, depending on what you're multiplying by. So that's what's that meant by dilation. Okay, and I do want to get to roughly the same place as the other class. So we'll get up to the middle of page 4, and then we'll stop. Because I want to make sure we're at the same pacing as the other classes. And that the project's obviously more critical, so we should spend some time with that. Okay, so let's take a look at this one here. So here we got another dilation situation, right? We have A to A prime, B to B prime, C to C prime. So which side of A prime, B prime, of triangle A prime, B prime, C prime corresponds to BC? So BC, if I circle it, is right here. So what side would correspond to it? That would be similar, not the same size, but in the same position or same orientation, let's say. Yeah, B prime, C prime, correct, right?
same for A.
Correct.
B.
So it'd be A prime, B prime. And you want to draw the... Peter, what are you doing, dude?
I'm trying to put this lab back in.
Okay, it's fine. It'll be okay. All right. Now, what I want you guys to do in your table groups is try to answer the rest of these questions. I'll come and help you guys out. I'm curious to see what responses you guys say for these. And I'll come around and help you guys out. So basically, guys, you and your table group members will do parts A, B, C, D. So what's the relationship with the corresponding sides? That is, how can you get the links of that from that? So I'm curious to hear what you guys have to say about that. For part B, why does A prime, B prime lie directly on AB? And like A prime, C prime lie directly on AC, but B prime, C prime does not lie directly on BC. And C, could you get the side lengths of A prime, B prime, C prime by adding the same amount to each side? Try this and explain what happened. There's a few other things as well. So go and try it. In about 3 or 4 minutes, I'll check in to see how you guys are answering these questions. So do your best to answer these questions in your own words among your table group members. And then we'll check in. Then we'll do the top half of page 4 after that.
Go.
Okay, yeah, that's fine. So you're all by yourself? I'm sorry. You can dress the bean if you want. You can sit next to her. Okay.
Okay, so it's on.
You feeling solo?
Lucas, those are cool pants, by the way.
Thank you.
Yeah.
Yeah. I don't even have my phone. Yeah, man.
Let's say one more time.
I really like the color.
I'll type up some responses and I'll walk around. Just trying to answer parts A, B, C, D on that first page.
Next time, no, I'm saying, you'll probably see him before then. Yeah. But like, next time.
Okay, yeah. Oh, God, God. It says.
He's like, really, really open up. No, I don't really know them, but they're nice. I'm just dancing both of them. But I really like that. It's like really, really fun. Maybe gold. Oh, yeah. I like. Other than. Yeah. She's not, she's just that she's.
Cowboy hat.
Yeah, right. Can I see it?
It's a cowboy hat. I got a reason.
That's not even bad.
Place that I got. Yeah. I'm not having fun.
Guys. Oh, yeah, I plugged back.
I got.
Oh, it's been good. I've been very productive. Got grading done and a lot of emails today. I didn't have to teach too much.
You have the thing today after school.
What thing? I'm doing that. Yeah, exactly. Oh, well, there's also a meeting after school with all the educators because some stuff has gone down recently.
Either,
Yeah.
either.
Yo, what does one even do during X period? Like, I haven't heard of anything to do in X period.
Go home.
Yeah, but I mean, like, is there even clubs?
Yeah, like maybe like yearbook or
Did
heartbeat.
anyone do that?
Yeah. Or there might be some other.
Like a Y period, but I don't. Wait, so if I don't go to a SHPTV thing, will it still be on my resume? Because my name is on there.
I mean, I don't know if you should put it if you haven't done much for it. I guess you could list it, but yeah, you shouldn't do that. Yeah.
You can, but like depends on what. Like, what would you like, bro?
That's just BTV. You got like.
Because there's some stuff you have to like prove, like they can find that out themselves.
Fact check every single.
If it's something like SHPTV, you can lie about that.
No, you shouldn't.
All right, guys, let's move forward. All right.
That's Peter with Denver, though.
All right. Okay, guys, let's get back. So for part A, what I said here and what you could say is that the corresponding side lengths are proportional. That's really the observation you want to make. Like, what relationship are you noticing among the sides? So like AB is like I'm not gonna try to get. Well, actually, let's look at AC. That's easier. How long is AC? From A to C, how what's the distance?
The screen that's gonna take me forever.
Yeah, I'm not going anywhere. Yeah. Well, probably 35 minutes, not forever. Okay, but yeah, but how long is AC?
Oh.
And how long is A prime C prime?
Oh, 6.
6, perfect. So you're just doubling. And the other side's gonna be the same thing, B, C, and B prime C. No, it's like no, there's math. You have to use math to figure out, yeah. So I guess yeah.
Uh-oh.
That's mean. I'll save 2x. So. No, just kidding. No, I'll go ahead.
Would it not? Start from that the point of origin, that's why they're.
Yeah, exactly.
Oh.
Right. Correct. Yeah. So the bottom line is that the ratios among corresponding sides are always going to be the same. So like, A prime C prime to AC, or B prime C prime to BC, or A prime B prime to AB. Those are all going to be the same ratio. It looks like we're doubling in each case. Then for part B, why do those sides, A prime, B prime, A prime, C prime, like directly on the lines they correspond to, but B prime, C prime does not. That's because we're stretching along the origin. We're not doing that for BC. For C, could you get the side lengths by adding the same amount? No, you don't want to add the same amount because then you wouldn't be proportional. So for example, like what if your sides were I'll write on the board. Actually, let's talk about this. What if I had a 3, 4, 5 triangle, which is by the way a right triangle? What if I added just 3 to each of those sides? That's not gonna be a right triangle anymore. And we know this because remember we had this on the test. 25 equals 9 plus 16. 64 does not equal 36 plus 49. In fact, actually 36 plus 49, read that to 64. This was actually a question somebody had some trouble with on our test. When this happens, that's going to be 85. That's greater than 64. What kind of triangle would this be when you do a squared plus b squared and it's more than c squared? It's a cube, exactly. So it's no longer a right triangle. So these would not be similar. So you can't add the same number. If I add 3 to each of these, that doesn't make sense. If I did want to make them similar, what could I do? Times by what? Yeah, or 2 or whatever, right?
2, 3.
And that's totally a right triangle. Right? Because that follows Pythagorean theorem. So you can't just add the same number. You have to multiply. It has to be a multiplier. Well, sure, yeah, of course. Yeah. No problem. All right. So the screen is still frozen. But go ahead and do part D if you haven't done part D yet. And then take a look at the next page. And try the one with the dog. Try 12, 3, 12, and 3, 13. And we're going to stop after the dog. So after we do 313, we won't do 315. We'll save that for the next day. Because that's where Mr. Davis' class left things off, and I just want to be at the same place as his class.
Where did they go?
After 313 on the next page.
Mr.
No, I
E.
don't know the answer to D.
So
Mr.
for part B, this one?
Yeah.
Yeah, so for part B, because line
No,
A-
D.
Oh, we're gonna get there in a moment. Are you good?
Yeah.
We're good. Okay, let's move on to part C. Let's talk about it. Yeah, Peter, sorry, go ahead.
Says like
Hmm?
she knows the like. Oh wait, never mind.
Okay.
When she means like AB, we have to like find the length of the line, or can we do it like
For which one?
D?
Yeah, let's look at D right now. Monica dilated triangle ABC to get a different triangle. She knows that A double prime B double prime is 20 units long. That's a little tricky because you guys haven't learned Pythagorean theorem yet, but that's okay. Actually, yeah, we should probably talk about it. Actually, no, sorry, we have done Pythagorean theorem. What am I talking about? Of course you know how to find that. How long is this side? 3. And that's 4. So if you do Pythagorean theorem, how long is AB? 5. What I meant to say, you guys haven't done distance formula yet, but distance formula is an extension of Pythagorean theorem. So we know AB is 5 just by doing Pythagorean theorem. So now, how many times larger would the new triangle be? 3, 4 times longer, exactly. Yeah, since AB was 5, and since A double prime, B double prime was 20, then the new triangle is 4 times longer on each side. Because you have to maintain that ratio. So how long would B double prime C double prime be? Well, BC right now is 4. To be 16. You got it. Yes. Good work. Correct. 16. Because when we noticed the ratio between AB and A double prime and B double prime was a 4-to-1 ratio. We noticed 5 from the diagram on the
Yeah.
page. And they told that A double prime, B double prime is 20. So you have to maintain that same ratio for all the other 4-to-1 sides.
Okay.
So that's why we multiply it.
Okay.
So this is introducing the concept of similarity, which we really dive deep into the second semester. Go ahead. Yeah.
Right. And we're not.
You would not get a right triangle. You would not, sorry. You would not. My apologies. Because it would not be similar. I did a little diagram up here where I did 3, 4, 5. So if I added like 3 to each side, I would get 6, 7, 8.
And,
which would cease to be a right triangle.
oh,
So,
okay.
so in order to maintain a right triangle, I have to multiply, not add the same number.
Get it right triangle.
A squared plus B squared equals C squared. Yeah, our Pythagorean theorem. All right, let's look at the image of the dog. When two figures are related by a series of transformations, including dilation, they are called similar. Okay. Some figures have the same shape but not necessarily the same size. Some figures can be created by multiplying each side length by the same number. We call it the zoom factor. So in this case, what's the zoom factor of the puppy? 3.
Three.
There you go. Pretty easy, right? Because you do 15 divided by 5. Easy peasy. So what would a dilation of a zoom factor of 1 produce?
It would be smaller.
No, if the zoom factor was 1, you multiply by 1. Would it change? It would not change, right? So they would be similar, but they would be identical. Because if you have a zoom factor of 1, that means you didn't change it at all. You kept it the same.
Wait,
Like,
But
it's like a
like,
scale of like
you
1
have
to
like-
1.
oh, you're multiplying.
Okay, you have,
I thought you would like at this,
No worries.
same number of one.
So like, if you, I mean, I don't think, do any of you guys use a copy machine at all these days? Not really. Some
Sometimes.
do. Well, there's a button where you can use the zoom in and zoom out. If you keep the zoom at scale 1, nothing changes, right? But if you zoom 2 or zoom half, it changes.
Yeah.
So that's all that's happening. Okay, this is perfect timing because we're halfway through class. So the rest of the time, I want you guys to work on your project. So I'm gonna give you guys poster paper. Figure out who's going to trace the image onto the poster paper. And very, very important, very, very important. Make sure you draw your scales nicely and neatly. If you need yardsticks, we'll have one here.
Yeah.
I thought we had another. I thought we had more. That was it. I should have.
It was not-
We can use rulers, but you can draw your axes nice and straight. Make sure they have enough space for all the quadrants. If your partner is not here, you could work on it. I know, as though your partner's left.
Yeah,
But you can work on the homework if you want, so it's up to you. I'm hoping to dedicate more class time on Thursday to the project.
Can I see my test?
Sure, yeah. Let me just pass it over. So,
You read Lucas?
thanks, Peter. I was at the whole.
Making sure everything. Wait, Mr. Period today.
Yeah, if you want to come do like that for work on the. Yeah.
If I.
I love that.
But how do that today?
It would help.
yeah, but that's
No,
fine.
no,
So,
it's not If you want, I mean,
This you did. You went all
yeah, I mean, the camera with the other
You're
prerequisites, I think probably it's like getting at least A minus for the semester or both semesters and getting, I don't know.
So
But I
basically,
want
I
to
can't
say,
be
like-
honors next year.
I mean, I don't know the full prereqs, so.
Wait, what do you need to get in? A minus?
Yeah, let me look at that actually. Let me see. There's actually, I think there might be some L minus with that. Oh,
So I don't.
yeah.
My
So-
minus.
So what you want to do,
Close.
okay. So what you want to do is try and draw your axes and be careful. Make sure you leave enough room for each quadrant. So, yeah, probably do if you can. And then
Wait, what even is the next class? Is it like algebra 2?
algebra, correct.
Wait, is it, but if you win an honors, I'll teach rate honors.
It'd be algebra trig honors, correct. Yeah,
And then regular is just algebra 2?
correct, right.
So what about like the trig, like trig, like is it like, is,
Yeah, is there a whole
Oh,
separate
sorry.
class for trade?
Well, you do some trig in regular algebra 2 or at level algebra 2, but you do more because then the expectation is that you would move on to
Or like-
pre-calculus.
You're in
Honors.
algebra 2, then what after that?
Then you would do, you could do actually at level pre-calculus or pre-calculus AB honors, depending how algebra 2 goes.
You could take honors from algebra.
So for example, if you feel like you're not ready to do that leap to honors next year, you can hold off on that and then make that leap the year after your sophomore to your junior. I've had some students do that. And then you would be in a position to do AP calculus as a senior, if you want to be on that trajectory.
wait,
Um,
AP Calc as a senior year class?
Correct. Actually, we have some students who wound up doing AP Calculus BC as seniors who took this class initially. Then they took, well, you're a sophomore, right? Yeah. So that wouldn't happen until college, um, but yeah, we have freshmen who.
That like is the advanced topics class like after.
Oh, that's if you're a freshman starting Altitude Trigonometers and you do AP Calculus as a junior. Correct, because you read AP Calculus as a junior, right?
So he's just like him basically.
But you could, if you're a freshman starting in geometry, you could technically
I don't even want to take it.
you could do stats, you could do whatever you want. And honestly, it's 3 years from now. There's a lot that'll happen in 3 years. Yeah,
Or does Sydney take calc?
yeah, they do want to see calculus at
But
the.
they didn't care.
But I've seen students who have not done calc have done
They
fine.
see
I mean,
stats, that's
yeah.
fine.
Yeah, exactly. I've seen.
They like.
I think they prefer it because they do feel it's has a little more rigor. That's the the thinking.
Depends like what your major.
True. Yeah, if you're not majoring in STEM, it won't matter. Yeah. Yeah, college is it's a funny game. It's a lot of weird stuff happens. Yeah, if as long as you meet certain thresholds, like okay, like you've taken pretty good classes, pretty good grades, pretty good test scores.
Actually, it depends where it still matters. But like,
Well, water polo is a different thing because the top water polo schools are usually the top academic schools
Yeah.
too, like Stanford and Princeton and Harvard and even USC.
I'm not a water polo.
But I mean, since you brought it up, so like we have one particular player who's going to USC, who she's just really great at water polo. So if you're really great at it, then you just have to kind of just meet certain thresholds for the academics. She's really good at water polo.
I mean, yeah,
She's nationally recognized. That's
they're not there.
but like your brother's going to Princeton. I mean, yes, that's an Ivy League school. You would definitely need to have a school. A school like Princeton is going to be a little more strict about the grades. Whereas USC plays Division I sports, Princeton does not. Right.
I love
So-
my brother like becomes the greatest player of all time. I'm not great at stuff.
Oh yeah. But it depends what you want. Like if you actually see yourself playing professionally, then yeah, you should play at a college that's going to get you to that next level, right? But if you want to like just focus on school and maybe go get a business degree or go to do a career afterwards,
That's why he went to.
yeah, then choose a school like that. Yeah. So it's just
He went there instead of UCLA because like there's no money in water polo. Like he has to do something after college.
yeah, you don't make much. Yeah.
Job like
Yeah. Yeah.
he's gonna be.
I have one student who did play professionally, but she did it for a few years and then quit after a while. We had one Olympian many years ago. For water polo kick. Well, Tiara does. She actually makes a pretty good living because women's soccer actually has a viewership. We care about women's soccer in this country. We don't care about women's water polo in this country. So that's. And Tiara actually, I was just talking to Mr. Davidson, like she doesn't quite fully capitalize on her social media exposure. Whereas like some of the more famous players like Alex Morgan or Rapinoe, like they're so huge soccer, but like they're so huge on like their social media that they're just making money left and right off that. So it just depends. Yeah, of course, yeah. Oh, I was recording all that too. Yeah, all that just got recorded.